Here is a two dice simulation, the two dice simulations. You see that it has around 3000 values, and we have got experimental probability, theoretical probability, and the frequency which your dice are getting rolled. Let me show you how. You can see there are 3000 values. Let's go to top and get started. This is our topic. You can see dice 1, here is dice 2, and here is a total of 4 dices. For dice 1, the formula is rand between. We use between because we can give it a range where it can give a random number. For 1 to 6, you got total, and you have to sum both of them. There you go. Now you have got at least 1000. You can see if I do anything here, it will automatically change the random values. Automatically rolls the dice. You can do it by pressing F9 as well, or doing anything else. Now we have to copy that formula and go for our 1000. Let's go for 2000 values. There you go. Now you have 2000 dice rolls, and you will get the probability of it. You have to count the rows. Now before counting, we should convert it to the table form. There you go. You now have a nice table. Now count the total number of rolls, dice rolls. It is much easier in table form than in a text forms. Table is better for if you have something like that. So we've got range from 2 to minimum 2 to 12. Because why we are getting minimum 2? Because there are 2 dice rows and minimum value can each dice have is 1. So 1 plus 1 is 2. So we will get maximum value of 12. You can put the values without the formula. There's nothing to worry about. I hope to get that formula, but there's something problem, so we have to adjust the formula. Plus 1. You have to go to maximum 12, so delete the every other number. Now you have got the range. Now it's time to get to the frequency. For frequency, there is a formula called COUNTIF. COUNTIF sets a condition to the counting. You will give a range of sum, the value that it represents, and the next you will give it criteria, how many times a certain number came. So for 2, it came for 70 times. Now you have to change each of these number, 3, 4. You can also give criteria a cell from the range, so you have to drag it all down, but I like it this way better. Now you are getting range. Now it's time for theoretical and experimental probabilities. Theoretical probability is what you have read in your books. Now let's look better. Theoretical probability and experimental probability. Alt HOI, and there you go. The theoretical probability is simple. You have to divide from 1 to 6 and 6 to 1 to the 12. No, not to the 12, to 36. 1 over 36, you got 2 over 36, 3 over, and so on, up till to the 6. And then you have to reverse it from 5 to 4 to 3 to 2, and then 1 again. So you can calculate it if you want. I am going to copy it here. Trick is that after the 6th amount, you have to reverse the dividing from 6 to 5 to 4 to 3 to 2 to, and then 1. In experimental probability, you will divide the value of frequency with the total number of inputs. Here, total number of input. So you have to make input still. So we put the dollar sign by pressing F4 here to the value. Drag it all down. Increase the number of zeros, and there you go, you will have it. Now comes to the visualization. The visualization is relatively very simple. We've got range and frequency. Insert table. I like the bar chart here. You can choose. You can see that it also displays a range. So we don't need the range. We only need the frequencies. Range is written there. You can do each and every tab like this. Put a frequency, exclude the range, and apply. Go for here, change the color. And there you go. And then for the experimental probability, select both of them, and then you'll get the bar chart. Now you've got a nice looking system. Every time you pull it, the probability will change. Oh, I think there's something missing here. In the chart we are getting the values from 1 to 11, so I think I am going to change it. So to change the values, when we are getting here from 1 to 11 and here 1 to 11, not 2 to 12. So to change the value, simply click here, go for here, go for select data, and remove range from here, edit, provide it a range, and OK. Now you've got from 2 to 12. Similarly here, select data, remove the range from here, edit, OK, 12. There you go. Now your 2 dice simulation have been completed. When you will do anything, for example, I write A, B, it will automatically change the value. Theoretical probability is constant because it is theoretical. Experimental is what we are getting from it. You can see the experimental graph is almost equal to the theoretical. If you have less sample size, for example sample size of 12, 13, this graph will have a huge variance. So have a nice day. If you like the video, kindly subscribe my channel. Thank you.